Okay, in our little sequence here on time travel, we had the first one where we were talking about cause and effect on timelines, as well as the non-local spheres that are the neutron spheres. So we kind of cover some of the basic information on the more complex levels of sciences that are behind time travel. So if we're kind of saying, okay, if there is no time, as I explained in the two previous podcasts that are linked to this, and I know it's hairy, and I know it's not Harry Potter, but it's very hairy and very difficult to grasp these sciences. And even if we talk about within just the normal Einsteinian sciences and build up an understanding of wormholes and the bending of space and the speed of light, and how do you actually, if you are, let's play with if you are to do time travel within the Einsteinian sciences, and if you are to say, okay, I want to go from time. Here we have to work with the idea that time is irreversible, right? It goes from the beginning of Big Bang and it will end in Big Crush, in the Big Crunch, if they have got that one right, which we know is not the case because there's something prior to this structure and there will become something after. But you kind of have to go through what we could call gate systems that actually does look a little bit like the idea of wormholes or a black hole, to some degree, but not completely. This is, again, we're talking alternate reality and inner perception of how the universal structure really is put together, right? So this is different. So it's not something, how does science come around this? Again, in my opinion, of course, remember, this is my opinion, this is how I see it. It's psychic, energetic investigation of a topic. Remember that. So this is not me saying, oh, I can drive evidence on this, I can do it, kind of verify it. The way that most today it's called mathematical cosmology. Most of the scientists that are working within these very hyperbolic kind of exceeded levels of what we can extrapolate from our observations of space, because when we talk about what is space and how it go far beyond what we can see with the Hubble telescope or whatever we send out in space, has to be theoretical, and that's why they use mathematics. So that's the way they drive evidence, by creating mathematical equations that they put into a computer, which they, by the way, have created and engineered the program for. So they are kind of running in their own little Ouroboros loop here, saying, well, we have that idea, we have that prediction, we have that mathematical code for it, we produce that program, and then the outcome, the output, what if we put it in and it comes out in the other end, is just kind of tying itself up in its own little loop, kind of saying, well, that's just what it is. And I'm looking for a specific word here that is a fancy English word that I learned when I was studying at the University of Copenhagen. It's called hermeneutics. Anyway, so this is these kind of things, and not hermetics as with Hermes, but a specific type of how we can actually create our own. We create our own solutions to our own questions, so to speak. So this is not really, that's kind of the scientific method today. And even though they say, oh, this is objective and all these kind of things, I just wanted to put that one in there, so we are on top of things. When we do study things and we do call a scientific method, we also know this is not as simple. This is not just about saying, oh yeah, this science know everything, or we know everything. Who knows everything? Nobody knows everything, right? We know different things. Sorry, I had to drink there. So with that one said, how do we then perceive time travel? First and foremost, there is no time. So how do we perceive travel from one point of space onto another? And that's where I wanted to go with the irreversible time. First and foremost, science have learned now that time can be reversible. But we have to go to what we call the deepest... Oh, this is going to be very complex, and I want you to check this out for yourself. When we're working with the macro scope of the macro level of these sciences, we're working within the electromagnetic fields and with the forces, and we work with a space that has gravity in it. And we work with heavy molecules, let's just call it that. So with that, we can say and we are working with the expansion of the universe. So that's why when we say, why is time irreversible? Because of the Big Bang and the expansion of the universe. So the universe is expanding. And that's where, again, when we talk about the constant, the Einsteinian constant, that has to do with that expansion of the universe and the shape of the universe. So again, we can say, well, was Einstein right with that constant? He made it up in a mathematical equation, or is this actually just one level of it that we can perceive mathematically? So what I'm here saying, and I know the ones that are within mathematical or theoretical cosmology, they will not agree with me on this one. But I'm just kind of saying, well, they're made of these mathematical equations. But they say, well, no, we can prove that. We put it in and we calculate and then we will prove it. It will come out with that output. We have the equation that A plus B equals something, right? We have that equation and that must be right because 1 plus 1 is 2. And if we make up that equation, if we put in these different parameters, if we put up these different kind of velocity and whatever they have calculated, and we put it in this and whatever squared, whatever number into infinity, well, then it will come out with that output. The output will be calculated via these different equations. But what if the equations are wrong? What if the equations are wrong? Because they're built upon a limited perspective of how the universe is built up. So that's the first thing. So when we talk about, well, time travel as in how do we, if we go, so this is, sorry, there's a lot of thought processes. It's like I'm opening up to a huge can of worms and they're all springing up my face right now. So let me select through the worms and say later for you, later for you, later for you. And then now just subsiding, crawling into the little wormholes. Haha, pun intended. So we're saying, okay, so we're looking into this and say, okay, time is irreversible due to Big Bang and the expansion of the universe. I am here claiming that the speed of light is wrong. It is changeable. It is not limited to a specific kind of velocity. It can change. It can change if the property of space changes. And then scientists will say, well, the property of spaces can't change. Well, it does. We have the expansion, so it does change. So the speed of light will change as well, because can we say that the quanta that are in the speed of light, that are in each little light quanta, if we have, they've got Planck constant and all these kind of fancy expressions that they come up with that they will use if you tell them that the speed of light is changing because the universal structure is changing, and that as we expand, then the speed of light must also change. It cannot be the same as it was in the beginning of Big Bang. And they say, no, it is, because of the microwave background, because of this, and because of the properties of space, and because how things are working, then the speed of light must be this same type of velocity. It's still the same speed because it's no longer connected to gravity. Okay, so we're going with that one. Say, okay, so gravity is connected to the expansion of space, but if gravity is a weak force, how can then that be the main provider or the main player in this equation? Anyways, I'm just questioning something here that if you ask me to make an equation on it and discern within the equations that they have made up for this, I will not be able to prove any of this because I'm not a mathematical genius. I did it at the University of Copenhagen a long time ago when I was younger. I was actually doing macro and micro economics, national financial systems, and all these kind of things. And I did mathematical on a higher level with all sorts of very fancy equations. And I just knew there that was not for me. My brain just doesn't want to work that way. So anyway, so I barely made it through, but I was good at some things and other things not so good at. So this is how we are, right? We're humans. Some things we're good at, others we're not so good at. Some things we excel and others we don't. But when it comes into this, if we talk about the ability that Einstein had and the ability that Niels Bohr, which is a Danish scientist, had, or anyone else, or Stephen Hawking, that are envisioning, seeing this in their minds, yes, there I can definitely double up this game, because there is some kind of things when you look at the properties of space and you really look at it from that level of whatever it weird feature in the brain that allows you to perceive and understand space and the universe by looking into it with your mind's eye. It's kind of a conundrum, right? But you look in there, I look into this whole universal structure, and I look into the ideas that they have behind this. So I'm investigating their ideas. I can't prove it, but I'm investigating the ideas. And then, of course, they will say, well, Randi, you have not studied cosmology for 20 years plus. No, but I can look into what I know and how I know things work from my other types of studies that they haven't done. And then I can compare psychic energetic investigation and comparison between the theories of what space is and what space isn't. And in that also understand that time travel is of course connected to space. It's about traveling from one level of reality to another. So let's put that one in and say time travel is to travel from one level of reality, one type of reality, into another. It's not just about traveling in time. It is also traveling in space, and it's also traveling in reality perception or reality expression. So we are having some new things we need to put in there, because what is time travel? So what I'm here unraveling for you, putting in all of these other stuff, is first and foremost, is the word time travel accurate? And I spent a couple of podcasts here saying no, because time doesn't exist. Okay, so what is it? What kind of travel are we here dealing with then? And I would say code stream travel. That would make much more sense to me. And that's how the different alien groups that are here, they're doing that. They are traveling code streams. So what is a code streamer? That's type of a holographic gateway that you kind of enter into the stream, and then you can be moved between different access points and nodal points in the holographic structure, from where you can shift your viability rate, or what we could call kind of energetic configuration, which allows you to unfold and come into beingness within other realms and within other types of energetic configurations. So it's all about the ability to understand how to work with energy in either via mechanics or via consciousness. So these are the two things. But I want to go a little bit further into why I don't see the whole Einstein-Rosen bridges as being the ones that we can kind of go with, or the wormholes in that manner. There is another piece of information I got from the future, and that is that there are Fermi bridges, and Fermi bridges goes with the quantum potentials, and it goes with the quantum bridges, and it goes with the quantum entanglement. So that's a whole other way of working. So that's one way that they learn in the future to travel back in time via the quantum fields, the quantum properties. But to do that, you have to calculate probability and possibility of the understanding of where these different types of bridges can seed into different sections of time that are connected to a specific probability field within the quantum field. So that's a whole other type of science. So if we first go in and say, okay, whatever we've been shown in movies is always this kind of travel in time. So where I wanted to go first was this whole, if we are to entertain the idea that you actually do travel in time. Well, there is this kind of, we always see it in movies. Well, the whatever we are, whatever, if in 2010, the world looks in one way, in 2065, the world will look in a different way. So this must also be calculated. It's not just about, this is again a reality perception, because if you travel in time, you are then working with the idea of a fixed space. And that's why I go in and say the space is not fixed, because it's expanding. So, and it's changing. And the stars and the planets and everything, they are, even though we are in different orbits that are around the sun, and science will tell you they are in these orbits due to gravity. But gravity is a weak force. So how can that even be? And then they say, well, it's because of mass, it's because of the property of space. And we know if you go out into space and you are pushed, for instance, away from your spacecraft or whatever, you just spiral into space because there is no gravity. So this, for me, not knowing all of the fancy levels of science is just kind of, yeah, that doesn't add up. And that's because I'm one of these weird people that don't believe in gravity. Duh. Wow. by Einstein, yes, of course things drop to the ground, but I am one of these weird ones. Not that I am going into the whole ideas of all the ones that are talking about the electromagnetic universe, and these are, and they got all of very, very good explanation, all of their ideas that are still within the Einsteinian sciences. But instead of gravity, like Newton told us, they are working with the electromagnetic fields and the magnetic pole, which I agree on. But this is due to other properties that I will explain sometimes later, how I perceive that and how I see how the magnetic field via the Schumann resonance, via the ionosphere, via these different energetic fields that are around our planet, which we also have. So we are tied to the planet via our individual holographic energy system, similarly as our planet has a holographic configuration behind it. We are tied together via our similarity. That's called the law of energetic and genetic affinity. We are tied together via the similarity in our holographic structure behind this physical form. That is what ties us together. That's what's binding us on the planet. Because we're kind of, if you're in Australia, you are standing with upside down. How can that even be? And then we know, I talked about this before. Well, technically, we don't know what's up and what's down because the universe is expanding according to where you are as an observer. That would always be the center point, and everything else will unfold as it is. So if you're standing in Australia, that will be up for you, even though it is not up if we think that space has up and down, but it doesn't, because it expands around us as a spherical experience, so to speak, around who and what we are, both energetically, but also actually. So that's also why we don't know the limitations of space, because we're limited by the visual light. So we can only, within the spectrum of visible light, is only that what we can see as far as the universal structure goes. After, where the sun is no longer shining, we can't see, because that goes into a type of darkness. So what's beyond that? So we are limited. So this is why I'm not the one that goes in with gravity. The gravity is definitely there, but that's not the prime mover, so to speak, of why we are stuck to the planet and not fall off, why people in Australia are still standing upside down, and the properties of space that are interactive, which again, when we talk about these typical dynamics that science explains, so this is how it is. I'm always just kind of, when listening to that, I say, yeah, that's a very good explanation. But you know what? If I were a little bit more smart and mathematical, more sharp, then I would prove you dead wrong, because I know that's not how it is. But this is what they have to work with right now, and that's all good and fine. So when we go into that understanding, first and foremost, time is irreversible. And that's where I wanted to go. On the quantum levels, because of the entanglement principles, they have discovered that time, of course, is not irreversible, because you have the entanglement. You have between two different atoms work via entanglement. You can put one atom in front of you and the other one at the other end of the space. They will still react simultaneously to whatever is happening to one of the particles will also happen to the other. That's the entanglement. So that's the double entanglement principle, so to speak, that whatever happens to one type of particle that is similar to whatever is entangled with will respond in the same way. It's this kind of simultaneously instant response to what happens to one of the space will happen in the other end of the space. And that's the basic understanding of the Fermi bridges, where you begin to work with the quantum probabilities, and in that learn to what kind of state does this cluster of different forms of energies that are put together within a specific section of the quantum fields. So what is it that science needs to get into? They need to learn to understand the quantum fields. And we're not talking about fields like a magnetic field. We're talking about, again, these huge planes of possibilities that are hidden in what we understand as dark energy of the universal structure. So they will come to it eventually. Then they will begin to understand, okay, there's quite a lot of stuff here that we haven't really figured out yet, and why galaxies are positioned where they are positioned, and why their accretion disk begins where they begin, why black holes are positioned where they are positioned. That goes with the deeper understanding of the quantum fields. But we also understand the quantum fields are just the bridge into the artificial fourth dimension. So again, if we work with this, we are thereby understanding, okay, time is reversible. It can go back and forth via the quantum principles. So we are just looking at things from the wrong angle. And what science haven't cracked the code yet is to say, well, we do have time that can go back and forth, or in no time and non-locality, because in a way, time is connected to a locality, right? It's like when you are on our planet, if wherever you are on the planet, the sun will be in a specific position that will determine the quote unquote time of the day, on the day, as a kind of not off. You know what I mean? Is it 12 o'clock or is it 1 o'clock? That's the time. And at the same time, we have the dates. But technically, the only reason why we have the dates is because we have consensus-wise decided that we began with year 0. That happened around 30 years, give or take. Anyways, that's part of the Jewish calendar and the Roman calendar, and the decision about when that time began again as the supposed birth of Christ, right? So that's year 0, where everybody agreed. Those who were in the Christian orientation, they decided that's the new calendar. We begin there. The Romans had their own calendar. They worked differently with 10 months. And even though there were 12 months of the year, they only had 10 months. And then they had these 3 months where things were not really a month, but it was definitely running there, but they had no name for it. We have the Jewish calendar. That's a rolling calendar that changes all the time. And that's tied into the beginning of the world, according to the Hebrew Bible. So we can say, well, time as dates are not really existing. That's a human creation. So we have different. We wake up and we go to sleep. But if you are awake at night and sleep during daytime, your sense of what's night and what's day and how things are changing, what day it is, you feel that kind of loss of that structure because you're no longer adhering to it. And if you have no watch and you're not looking at time, well, then your body will naturally learn to orient towards the sun. I kind of grew up, I had a watch on my wrist, of course, but as a child, I learned to sense this is new, this is that. Like every person that's living out in coherence with nature will learn what time of the day it is due to the position of the sun. As well as when it's dark, it's night, and when the sun is there, then that's day. And that changes around a year. So days are not the same, which we also know with the different, we have had a lot of earthquakes on our planet, which has actually comprised the crust. So we are having, the day has become a little bit shorter, it's a little bit shorter, and time is moving a little bit faster, which also means that if we are comprising things and it gets more matter or more, which would be called gravity. The more dense it becomes, the more gravity it has around its the body of whatever we're talking about. So that's why a neutron star, for instance, is a very heavy thing before it goes into complete evaporation. It blows up. Sorry, I have the word in my mind, but I'm thinking about something else. So I lost that word. Sorry about that. But the whole kind of thing is that we understand that, okay, if our planet gets more heavy, then time speeds up. And that's due to the properties of the speed of light and the position in space. So when we talk about these things of, if things get more heavy, then similarly as we know it with a black hole is something that is so heavy and so comprised of energy that that's the Planck constant, that the speed of light and all things go into such, there is no light there, technically it's a black hole, right? But the energy is so compact and so high leveled that the gravity around that black hole becomes enormous because of the enormous amount of energy that is gathered there within a very, very limited type of space. And that's how they explain black holes. You can look that up and probably get a little bit of things here and there that I have missed in this explanation. Because as I said, this is not my science. It's not something that seems logical to me. That's not kind of how I see it. I see black holes as a kind of, similar when you look at the sun and you see when the gas clouds around the sun, kind of you have these coronal holes that are in the sun and you just look into emptiness. It's weird. You look into the sun and you look and it's just black nothingness that's in there, unless they manipulate with the photos, right? But that's kind of what you look at and say, that's weird. How can that be? A sun, we look at it every day and we think that's something that's tangible. Well, it's gas. It's nothing but gas and kinetic processes and helium and hydrogen that are burning off at an enormous rate. How is that? What's driving the sun for these kinetic processes? And they say, well, that's fusion or fission and whatever. They're coming up with all sorts of explanations. But it's still a conundrum, right? Science have got explanations, but it's not the same as the correct. They have looked at it. There has been ever back into whatever time of the dawn of civilization, there have been philosophers, right, and scientists pondering upon the different phenomena that we had in the world. How do they work? How they put together. So we're also having this, and then we say just because it's cold space does not mean that there's not some kind of kinetic process. Perhaps the kinetic process is happening on a different level. So that, anyways, I'm just completely got sidetracked there with the black holes and what have we. But when I look into a black hole, I'm looking, that's a gate, but it's not a wormhole. It's a gate into what's called the abyss. That's where you get sucked in there, you evaporate, you cease to exist. That's the gate into non-existence. So you can't use a wormhole to get somewhere. If you go into a wormhole or a black hole, you will cease to exist entirely. So yeah, not traveling that way, not taking the one-way ticket into that one. So that's kind of out of the question. And the high level of energy that is there, dark energy that is gathered there, that has that enormously gravity around it, that's because it's part of the previous universal cycle. Black holes are the sign of where our universal structure is falling apart. That's what a black hole is. So that's not a good thing, right? That's kind of, that's kind of the big glitch in the universal structure where the network begins to fall apart and no longer has a viability rate. Then it becomes a black hole. So when things stop having a viability rate, it turns into black holes, it turns into dark energy, it turns into previous universal structure type of energy. And there's only one way from that, and that's the evaporation and dustification. And the force that is there is entropy, chaos, the abyss, the Tehom, as it's talked about in the Hebrew Bible, and these kind of things. And there has been many civilizations and many different types of mythology, including whatever you will come up. You can talk to any person on this planet that has some kind of indigenous mythology. There will always be this chaos level, because our universe is divided between order and chaos. The Egyptians, the Mesopotamians, whoever, it doesn't matter, between order and chaos. And it's all a matter of how do we keep that balance where the chaos powers will not consume the powers of order, and where the order will not. Then the typical one is that, well, we need chaos to undo the rigidity, the structuredness, the crystallization of order, which can also lead into that where everything gets so ordered and so nice that the only way that it can get out of its own entanglement into this crystallized state is via chaos or via some kind of things that scatters it. Anyways, so that's the two oppositions we're dealing with, where we have complete chaos where everything evaporates and ceases to exist, or complete order where everything crystallizes and by that stop having any progression. So just saying we are working with the scales of dynamic here. So how does that apply to time travel? Well, it applies into the foundational understanding of what is it that we are talking about. That's the first step we have. We need to look at the concepts. Again, meta perspective. What are the concepts we're talking about here? It's not just traveling in time, because if time doesn't exist, if something we have made up, and the day and night are something that is that's happening because of the planet's orbit around the sun and the way that it circles around itself, the spin of our planet as it circles around itself, and certain parts of our planet are hit by the sun and others are not, and that's night and that's day, then it's just about what we call mechanics of our planet. planet that has very little to do with actual time. It's mechanics of our planet that spins around its own axis, and then hit by the rays of the sun on different levels of our planet, and similar with the moon. So we are saying we're having a triangulation there, just putting that one in, that is also playing in some of what we will call the properties of quote unquote gravity, or why we are in that orbit as we are in, plus the explosion of the fifth planet, which that has been mentioned in many other types of ideas, that what we have got, the asteroid belt, even though science says, well, it can't have been a planet because what's left there of the gravel is so little it could not have been a planet. Yeah, what if that planet was enormously heavy? What if it was a very, very small, very, very heavy planet? So what's there is just because you have an idea that a planet should have that size does not mean that it's not a planet. Similar as Pluto used to be a planet, but now it's just a planetoid because it's not big enough, right? What if that planet that is now the asteroid belt actually was a planet, but it was a very small one, it was a very heavy one? If that's the case, how did that change what we call the position of the inner planets? That would have kept them in a different type of orbit. And if you then move that very, very heavy planet and blow it up, then the orbits could expand. And that's why we have the current positions that we have them now. And there was a little bit of swapping around of the planets when that happened. So that's another thing science will say, no, that's not possible, because once a planet is in its orbit, it cannot leave its orbit. Well, what about electrons? They are in orbits too. They can jump if they get enough energy. They can become virtual particles. They can gather momentum, crawl up to a different orbit. And then, of course, if they fall back, well, then they burn off all of that kinetic energy, similar as our sun. So that's kind of what's happening there. So, and in that they will lose more of their energy and they will lose some of their ions. And by that, they will become more heavy and they will then fall actually further down in an even a different type of ring, or they will cease to exist entirely. And then other virtual particles will climb back up. And if they can gather enough momentum, become part of the different orbits or in the cluster around the nucleus. So we are having these, we've seen that with the atoms. So why is that impossible that happens with the larger bodies that are part of our solar system? Just putting that one in there as well. So I'm messing around with your concepts of what you think is right and what you think is wrong. So if we all together change the foundation, the parameters of our universal structure, the parameters of how our solar system is built up, and at the same time understand that time does not exist and that what you perceive as day and night are due to mechanics of our planet, that if you change the tilt of our planet, and if you change, which has happened, and if you change the way that the planet orbits around that tilt, if the tilt changes from being to the right, 30 degrees to the right, and go to 30 degrees to the left, and again, we can say that's technically not possible because there's no up and down, what have you, but play with that idea that the tilt changes from being in one direction to be the tilt in another direction. You will change the spin of the planet as well, and if you change the spin of the planet, how does that affect the orbit that the planet is in? Okay, so that will also shift the time of the day, as if, for instance, you would have, if we are saying you have the sun in the middle, envision this, you have the sun in the middle and you have our planet that orbits around. If the planet is tilted to the right, it means it's tilted more towards Mars. So the sun will hit the planet in a specific way as it moves around its own orbit, or its own axis. But if you tilt it to the left, then you tilt it towards the sun, and that will then change the way how the sun hits our planet in that kind of configuration, meaning that what normally would receive sun is no longer receiving sun the way that it used to. The sun will still be there, but the fraction of light will be different. And how does that diffraction of light as it hits the planet, how does that change the frequency spectrum? How does it change the Schumann resonance, for instance? How does it change the different features of the planet? And this is what I'm saying. That's one of the reasons why we have this heating of our planet, because we have tilted towards the sun, and by that are no longer having kind of what we could say as we were oriented more towards Mars, we would have a lesser surface that were hit by the sun. and a magnetic field would point towards Mars, and by that actually pull in energies more from what we would call outer space. But because we've been tilted the other way, our magnetic field are now more oriented towards the sun. And the sun has shifted its own holographic configuration from being what we would call a middle domain oriented, connected via the artificial fourth dimension to the middle domains, or the parallel stellar systems that are in what we call the holographic reality fields, and is now coming into what we call density 1, or the original configuration of the sun, as it were, in the earlier stages of our solar system. And then you say, well, how does that add up? Because the sun is warmer now, and it will then become a cold sun. Yes, but that's because it's now burning off all of this artificial architecture it normally shouldn't have. It's burning all of that off, and that's producing enormous kinetic energy, and that's part of the CMEs and the solar burst and whatever's going on is shedding off an enormous amount of energy, and at the same time we're tilted. So of course we are getting, things are heating up here, literally the ionosphere is hotter than it normally is, and that will affect the magnetic field around our planet, and that will affect the whole planetary structure as it is, and that's part of what we call the terraforming that's happening right now. So that's what has that to do with time travel? An enormous portion, because if you are moving, if the place where you exist are in one tilt, and the magnetic field around it, the configuration of it, energetically speaking, is tilted in a specific type of degree and has a specific type of axis that allows it to work with specific amounts of energy from its core domain, which technically is the sun. And if it tilts the other direction and then it heats up, then that will also change, first and foremost, the way that we are having the time of day, how many hours of light and how many hours of light we don't have. We could begin to ponder upon, perhaps that's part of the crisscrossing on the sky that kind of takes away this whole visibility, the cloaking that whatever's going on out there. Plus, we also know the huge burst of energies from the sun are actually preventing cosmic radiation to hit our planet, to go into our ionosphere, which could be taken part of what we could say the upgrading into the artificial fifth. That could also be part of it, or disconnecting us from the inner domains, or whatever possibilities that might be there. I haven't got that fully completed, figured out what that actually means. But there is definitely something at play there. And at the same time, we can also look into saying, okay, if the Schumann resonance is changing its configuration and the ionosphere is heated up, how does that then affect what we could call the human genome and us that are in that configuration tied to the planetary configuration? If the planetary configuration changes due to the changes of the tilt and the orientation towards the sun, the way the magnetic field is working, well, then that will affect our configuration as well. And that's some of the reconfiguration work that I'm beginning to figure out, okay, how do we do that in the Higher Order Density 1 Work Institute? So with that, again, breaking down all of your concepts here, we can then begin to discuss, okay, what is it? What does it mean to travel from one nodal point in what we perceive to be quote unquote time, or different times of different forms of existences? We're traveling between different forms of existences within different forms of energy configuration, within different forms of property of energy, within different possibility and expression of existence, within different configurations of realities. That is what we're talking about when we talk about what is time travel and how does that actually work. And with that, I will leave this recording as it is here. Thank you.